Okay, now we're ready to wrap up Law of Sines and Cosines. Let's do a quick review. So far we've looked at Law of Sines. First, most straightforward case, two angles, one side of a triangle. Law of Sines. In the last lecture, we looked at one angle, two sides, and with what we called the matching pair, which I'm not going to explain again, we're able to use Law of Sines, but there was a lot involved here because this is where we have three possible outcomes. We can have actually no triangle, one triangle, or two triangles. So we went through all that. Now, we're going to look at the same setup, one angle and two sides, except the difference is we don't have any matching pair. And in this case, we have to use Law of Cosines, which we've not really talked about yet. So let's go ahead. There are three different parts of the Law of Cosines according to what information you have. Let me just write them down. A squared, this is the side A, equals B squared plus C squared minus 2BC times the cosine of A. So if I look at this, what's interesting is I have all three sides represented here and then one angle. You notice over here by itself is the side A squared, which lo and behold gets matched up with the angle over here in the cosine. And this is a pretty messy equation. In a few minutes, I'm going to talk about at some point in time, you have the choice whether you would prefer to finish the problem by using the Law of Sines or the Law of Cosines. The advantage of the Law of Sines is the equations are simpler and easier to work with. But there is a disadvantage to the Law of Sines for that situation, but we'll talk about it in a few minutes. But this is a pretty messy equation. I have another Law of Cosines if I want the B squared over here. And you can see these all start to look very similar. So here's B squared, over here is the cosine of angle B, and I've got some A's and C's in here. And then I have a third Law of Cosines if I want C squared over here. So then it's A squared plus B squared minus 2AB times the cosine of C. So the three are all similar, and it's just as you're working problems, you'll have to just determine which one of these is appropriate. It's not too difficult. Let's just dive in and work a problem. How about I'm given angle A is 52 degrees. Side B is a length of 22. And side C is a length of 35. So here's one angle, two sides, but non-matching. I mean, some of these aren't really hard. If someone tried to use the Law of Sines of this, they couldn't do it. They don't have enough information to even use the Law of Sines. So it's not like you're going to do something wrong. The Law of Sines won't even work here. So hopefully you realize, oh, this must be one where I use Law of Cosines. So which one am I going to use? Well, since I know angle A, obviously I need to use the Law of Cosines that involves the cosine of angle A. So it's its first one. And basically, if I use the law of cosines, this is going to help me determine the length of side A. So I'll just plug in all I know. So b squared, 22 squared, plus c squared, 35 squared, minus 2 times b times c, and finally times the cosine of A, angle A. So like I said, that's a sort of a pretty messy calculation. Let's see if we can not make a mistake here. Cosine of 52 in the degree mode times 35 times 22 times 2. I got like 948.12. Then I'm going to add to it 35 squared, which is 1225. And add to that 22 squared, which is 484. By the time I'm all done, $760.88. Take the square root of both sides. Looks like A is going to be 27.6. All right. Sort of messy math, but it does give us a way to find side A. Now here's what's interesting. At this point, let me write down what we know. The original information was angle A was 52 degrees. We now know side A is 27.6. Side B is 22. And side C is 35. Now at this point, actually now, you have an option. We've got to finish this triangle. Since the math is easier, some people want to jump back and start using the law of sines, which you can do. Nothing wrong with it. But you could keep on using the law of cosines, and you'll see in a minute why some people might want to go on and use the law of cosines, although the math is messier. So if you decide I just prefer to use the law of sines, there is a catch. If I'm using the law of sines for this, I have a choice. My matching pair are angle A and little a. So for the law of sines, the next step would be to go find either angle B or angle C. And it's up to me which one I want to use. Well, I say that, but it's not really. Because for this method to work, you cannot just choose whichever angle you prefer to find next. It has to be a certain angle or you will get the wrong answer. So what you have to do is you have to remember this. Use the shortest side left. In other words, I'm choosing between B and C. B is a length of 22, C is a length of 35. Because B is smaller, for me to get the correct answer, I have to next use the law of sines to find angle B. If I were just to decide at this point to use the law of sines to go find angle C, I would end up with a wrong answer. So yes, at this point you can make your math easier by using law of sines, but you have to remember the rule to now go to law of sines. The next step, you have to use the shorter side. So let's do that. So I can just say, I'm I'm going to do sine of A over little a. Since B is the shorter side, so I fill in everything I know. Sine of 52 degrees over A, 27.6, equals the sine of B, which I'm trying to figure out, over little b, or side B, 22. Sine of B would be 22 over 27.6 times the sine, 52 degrees. So sine of 52 degrees times 22 divided by 27.6.628. Now to find B, I take the inverse sine of both sides. Angle B ends up being 38.9 degrees. And now that we know angle A and angle B, we can easily find angle C. By knowing they add up to 180, I'm just going to write the answer down. Angle C is so in summary, if I want to write my triangle over here, angle A is 52 degrees, angle B 38.9 degrees, angle C is 89.1 degree. Little a was given as 27.6. Little b was given as 22. And C is 35. Now, at this point, after you do the initial law of cosines, if you can't remember or don't want to have to try and remember the rule for using the correct angle, you can just go on and continue to use law of cosines, and you will get a correct answer, and you won't have to worry about, oh, which angle should I figure out next? It doesn't matter. So if you don't want to memorize this rule, then just skip law of cosines and do the whole problem with, skip law of sines and do the whole problem with law of cosines, and that's no problem. Okay, one last problem now. So far we've covered all possible combinations except for one. At the very beginning I said if you're given three angles, we're stuck, we cannot determine the triangle. And then we said, okay, now how about two angles and one side? And that's an easy use of the law of sines. And then we spent a lot of time on the situation where you have one angle and two sides. If you have a matching pair, you use the law of sines. If it's a non-matching pair, you have to begin with the law of cosines. So the last possibility now is just three sides. So if you're given a triangle with three sides, then here's what we do. So we're given a triangle. Side A is 62. Side B is 48. And side C is 41. And they want us to find, obviously, the rest of the information for the triangle. In this case, the three angles. So we're not given any angle. Actually, let me do a separate problem. I'm sorry. Let's say A is 25, B is 30. For these, I have the answer. So as I'm working this, I can make sure I don't make a mistake and mislead you. So anyways, we're given A, B, and C. We cannot use law of sines for this, but we can use law of cosines. And really it's my choice, because law of cosines, you notice all three of these involve sides A, B, and C. Then each one has one angle, either angle A, angle B, angle C. So I just have to pick one of these, and I'm actually going to solve it for one of these angles. I might as well just choose the first one. So it's A squared equals B squared plus C squared minus 2 times B times C times cosine of A. So anything in here I don't know is the cosine of A, so it gives me a way to determine this angle A. Once again, the math might be messy. Let's go ahead and let's take 25 squared. Let's move the 30 squared and the 35 squared over to the other side. So I'm going to have 25 squared minus 30 squared minus 35 squared. I end up with a negative 1500. And let me multiply 2 times 30 times 35. 2 times 30 times 35. I have negative 2100 cosine of A. So if I solve for cosine of A, .714. Take the inverse cosine of both sides, and I get 44.4 degrees for angle A. Now you're back to the previous problem. If I want easier math, I can go off and now use law of sines. But of course, I have my special condition about using the shortest side. And if I don't want to have to try and remember that special condition, you can finish the problem just using law of cosines 2 more times. For me, since this video is getting long, I may use a law of sines. So once again, I have a choice now. I can go try and find angle B or angle C. I need to choose the one with the shortest side. So B is 30, C is 35. I better choose B. So I'm going to have sine of A over A equals sine of B over B. So I start putting the numbers in. Sine of A is sine of 44.4 degrees over A is 25, and the sine of the angle B, which is what we're trying to figure out, over the side B. The sine of B is going to be 30 over 25 times the sine of 44.4 degrees. So 30 divided by 25 times 44.4 sine 0.840. I'm going to take the inverse sine of that. 57.1 degrees. And now at this point, since I know angle A and B, I can just subtract them from 180. When you do that, you get angle C is 78.5 degrees. So in summary, this triangle, angle A is 44.4 degrees. Angle B ends up being 57.1 degree. Angle C is 78.5 degree. And of course, they gave us the three sides, but I'll go ahead and just write them down. Side A was 25. Side B was 30. And side C was 35. All right, so we've covered all possible triangles. Once again, a triangle has 6 parts. They're going to give you 3 parts of the triangle and have you figure out the rest. And now we've covered how to do all possibilities.